Hello, Algebra 2 students. Today we are going to do 5.4 notes called Factor and Solve Polynomial Equations. So last time we factored was in section 4.4 when we learned how to factor x squared plus bx plus c. So that was a quadratic in standard form, and we made an x factor chart. Then we also learned how to make it when a was not 1 and it was any number other than 1. We're going to do something similar, but this time we're going to factor polynomials. So not only have we factored quadratics, we're going to factor polynomials. So um, anything with a degree of 2 or more. A factorable polynomial with integer coefficients is factored completely if it is written as a product of unfactorable polynomials with integer coefficients. So I will give you an example of something that has been factored completely and then something that has not been factored completely. So you have 2 times x plus 1 times x plus x minus 4. Now it's factored completely because if you look inside the parentheses, the greatest common factor in each set of parentheses is 1. That's when you know that something has been factored completely. The next, for not something that's not factored completely, I'll show you. And you might think that's factored completely because if you look in the parentheses, the number in front of x squared is 1, and then you have your 4. However, that stuff in parentheses is that special pattern I told you about called the difference of squares pattern. So why is it not factored completely? And the reason being x squared minus 4 is a difference of squares pattern. And hopefully after I show you this, you'll remember what difference of squares was. I said that if you have a minus between two numbers, it can only be 2, then as long as you can take the square root of the first and last numbers nicely, then you can factor it. So the 2 you already leave out here, and that factoring pattern consists of two parentheses, where the first term is going to be the square root of x squared, or whatever it is, y squared or y to the 10th or whatever. And the second number is going to be square root of 4, which is 2 and 2. But because it's a difference, a positive number times a negative number will give you that negative 4 in that case. So one's a plus and one's a minus. And that is factored completely now. Okay, so we are going to factor this first three expressions completely. And the first step in factoring anything is to look for a greatest common factor. If there is none, then you proceed to the next step, which is looking for a pattern. So the greatest common factor of those three terms is y. And you don't divide by y. You never divide by a variable. You factor out the y, and then you create parentheses. Because remember, factoring is just the distributive property backwards. So you factor out a y, and so in order to get y to the third, you must have y squared here. In order to get negative 4y squared, you have minus 4y, because remember you factored out one of the y's, and the last one's going to be negative 12. And if you were to multiply each of those by that y, you would get what you started with. Now, you need to factor the stuff in parentheses. Because it's not a difference of squares, you will proceed to make an x factor. And hopefully you remember that b is for the bottom, a times c is top. So b is the middle term's coefficient, so negative 4, and a is 1, c is negative 12. So negative 12, I didn't need to put those numbers in there. So you have to find two numbers that multiply give you negative 12, added give you positive, or added give you negative 4. It's negative 6 and a positive 2. And so you would factor the stuff in parentheses, always bring down what you factored out in the first step. And you're going to put y minus 6 and y plus 2. And then it's factored completely. Okay, the next one, the greatest common factor, you can divide each of those terms, or I'm sorry, the common factor of each of those terms is the 3, but notice each of them has a minimum of an x. You always go with the lowest variable on the exponent. and the greatest common factor. So we're going to factor out a 3x, leaving us with, we already have the 3 that we factored out, so we factored out that 3. We factored out one of the x's, so we have 2 left. 3 times 10 will give you 30, but you need an extra x. And 3 times a positive 25 will give you 75, and you already have the x there. And then for the remaining stuff, you want to make an x factor. So b is a positive 10. A times c, so that's 1 times 25 is 25. Two numbers that multiply together give you 25, and the same two numbers added give you 10. So that is 3x times x plus 5 times x plus 5, or the lazy man's way of writing it, x plus 5 squared. And our last one of this type, where you have to factor the greatest common factor, you can factor out a 5, and they both have at least a g to the third, because that's the smaller of the two. So factoring out a 5g to the third gives us, well, we took out 3 of the g's, we have 2 left. And 5 times what number gives us 80? It happens to be 16. The minus sign from the minus in the problem, and we already factored out a g cubed. Okay, now you're not done, because remember, this is, if it's square rootable, if that's even such a word, and these two are, then you can factor it further. So 5g to the third. Here's what students want to do. They do everything right, but then they put 8 here and say, hey, 8 times 8 is 16, or 8 plus 8, but it's supposed to be 4 and 4. Okay, because the square root of 16 is 4. So positive 4 and a negative 4, and that's factored completely. Okay, so this section is hard because you're factoring many different techniques. So each of the boxes that I show you are techniques of factoring. So the first one in this section is called, these are special factoring patterns. And this thing right here that I put is just something to remember. The same opposite, always positive. I'll refer to that, known as SOAP. So the first pattern is called the sum of two cubes. When you see the word cube, you're thinking to the third power. So here's the pattern. A to the third plus b to the third. How do you factor it? The factoring part's on the right side. So you have two sets of parentheses. In the first set of parentheses, you're going to have 2 terms. In the second set of parentheses, you're going to have 3 terms. I'm going to leave it at that for now and just give you an example. So here's an example, and I'll say factor this. So the first thing you have to do is recognize it as a sum of 2 cubes. Sum, because this is a sum. Cube, because you can take the cube root of 27 and the cube root of 8x to the third. And so to think of that, when I told you about square roots, cube roots are just a number multiplied by itself 3 times, so the same number. And so the way to look at that is, what number multiplied by itself 3 times gives you 8, and it's going to be 2. Another way you could look at it is this. Put a cube root out here. Cube root. And then that makes it a little easier. And then you can say, okay, so the right side is, so make your 2 sets of parentheses. And here's where the same, opposite, always positive comes in. So same goes here, same as the original problem. The original problem has a positive. Opposite here, always positive there. So, and you're going to fill in the missing numbers. So the first number in the spot is going to be the cube root of 8x to the third, which is going to be 2x, because 2x times 2x times 2x is 8x to the third. And then what's going to go right here is the cube root of 27, which is 3. 3 times 3 times 3. Once you get those two, the rest of it's pretty easy. So what goes in here is going to be the 2x that you wrote first, and you're going to square it. So 2x times 2x is 4x squared. And what's going to go in the middle is going to be, and that's why I put the negative sign, because it's same opposite, always positive. And so what goes right after the opposite is just going to be these two numbers multiplied together, which is 6x. And then lastly, what goes in the last spot is 3 times 3, this number squared. So the first and the last numbers are squared, and the middle number is just the two numbers in the first parentheses multiplied together. Okay. Let's do a difference of 2 cubes example. Same principle. So we will do 64 x to the third minus 1. Okay, so you can take the cube root of 64x to the third. You can take the cube root of 1, which is just 1, because 1 times 1 times 1. Okay. I'll make this a little bit bigger so we don't run out of room. Here we go. So this original problem has a minus. So same, opposite, always positive. Okay. And so the cube root of 64 is 4. And the cube root of x to the third is just x, one of them. And then the cube root of 1 was 1. Okay. Inside the second parentheses, 4x times 4x is 16x squared. Multiply the 4x and the 1 together. And then 1 times 1. There we go. And that is factoring a difference of 2 cubes. All right, let's do 2 more practice problems. So as many as we do, the students still have problems with these for some reason. Just practice makes perfect, I guess. All right. So cube root of 27, 3 times 3 times 3, cube root of x cubed, x. Oh, let's do the signs first. So same, opposite, always positive. So cube root of 125, most students know that is 5. 5 times 5 times 5. Here, 3x times 3x. Remember 3x times 3x is not 9x, it's 9x squared. If you say x twice, it's going to be squared. And that's 15x 3 times 5, or 3x times 5, and then 5 times 5. The stuff in parentheses does not factor. It looks like it's going to, but all of this factors over the imaginary numbers, and we don't care about that. We care about the real numbers system. Okay, and the last one. Ooh, this one is a little tougher. We don't want the first term to ever be negative, so we're going to factor out a negative. In this case, both of those are divisible by -2, and they have a d to the second in common. So let's factor out a -2, d to the second, because this is smaller than that. So that's why we factor out a second. Okay, we took out 2 of the d squared, so we have 3 remaining for the first term. -2 times a -125 gives me 250, and that's it. And now we have to recognize the leftovers in the parentheses as a difference of cubes pattern. Right. And so let's bring down our -2d squared and then make our parentheses for the leftover stuff. There we go. I feel like I should make it bigger. So same sign, opposite, always positive. So this is going to be d. This is going to be 5, cube root of 125. This is going to be d squared, 5 times d, and 5 squared. Pretty easy if you get the hang of it. All right. The next one's one of my favorites. Well, I really like it. It's called factoring by grouping, and it only works if you have 4 terms. So the other stuff, like the sum of 2 cubes only had 2 terms, the difference of 2 cubes only had 2 terms. But then you get into this, whoa, I have 4 terms. How do I factor? And the pattern is in the box with the R, but I think it could get confusing with all the letters. So I'm just going to show you straight with the examples. So what you do is you group them into pairs and group these first 2 together and then group these second 2 together. Notice I'm going to group it with the sign. Okay, so what you're going to do is you're going to factor each of those individually. So you're factoring by grouping. So the first two terms, so just look at the stuff under the red or, under that area. You can factor out the greatest common factor of the stuff in red is 3 and r squared. So you're going to factor out a 3r squared. We haven't even looked at the stuff in green. So this is going to be 9 because that's the only way you can get 27. And you have to have another r to get the r cubed. And in order to get 45, 3 times, and this is plus due to the plus in the middle, 15. So 3r squared times 15 gives us 45r squared. I did that wrong because the greatest common factor is not 3, it's 9. So let's just erase that. Realize that when I noticed that I hadn't factored anymore. So you can actually divide 27 and 45 by 9. So it'd be 9r squared. So factor out a 9r squared. That gives you 3r. 9 times 5 is 45. Okay, for the next two terms, the greatest common factor, because we don't want the first term to be negative, we're going to factor out a -1. So for the green one, the greatest common factor is -1. So we're going to factor it out. I'm going to use the same color here. And so you just factor out a -1, so you'd get a positive 3r plus 5. And the reason why it's plus 5 is 5 times -1 gives you this -5. And the -1 times 3r gives you -3r. Okay, so now you look at what's identical. What's identical is this is identical to that. And when you see that one of those identical things goes in one set of parentheses, just one, just take one pair of those. And then what's left over that you don't have underlined, which is a 9r squared minus 1, goes in the second set of parentheses. And then you just factor if you need to factor some more. The 3r plus 5 is linear, so it's already factored. But this can still factor more. This is a difference of squares. And so this does not factor, so we're just going to write it out. The difference of squares factors into two parentheses, where one's positive and the other's negative. So the square root of 9r squared is 3r, and the square root of 1 is 1. And you put 3r here, put -1 there. And there, that's factored completely because it's all linear. Right. And now we are going to do one more of these factoring by grouping. So group those two, group those two. GCF of the first bunch is x to the second. And the GCR, the greatest common factor, of the second set of terms, so of these two, the greatest common factor is a -9. Right, so we can start with the first one. We factor out x squared, but we need an x to the third. We factor out x squared, but we need 7x squared. For the second set, x goes here. -9 times a +7 gives us -63. And then you look for alike things. These two are alike, but we just want one of those. And then in the second set of parentheses, my leftovers, that's what I call them. And then just make sure that the leftovers don't factor anymore. X squared minus 9 does factor. It's a difference of squares pattern. And so we have x plus 7, x and an x, the square root of 9, 3, and -3. That's linear. Then you're done. So that is factoring by grouping. I really like it, but then again, I like any kind of factoring. All right. This next thing is not too bad. I'm going to go over it. And again, the stuff in the box might not make sense with all the letters like U. And honestly, just go to the problem because the directions are always going to be simple in this section. Every single direction with factoring is just going to be factor completely. So if you look on the previous pages, Notice example 3, factor completely. Example 2, factor completely. Example 1, factor completely. So let's factor completely. We don't need to worry about the name of it. First step, is there a GCF? And there is. There's a 10 that you can factor out of both. Notice you can't factor out x to the fourth because the second term doesn't even have a variable. So 10 is our GCF, leaving us with x to the fourth here for the first term minus 10 times 1. 10 times negative 1 gives us negative 10. Here's the part that people have trouble with. The stuff left in parentheses does factor. And here's what you're just going to use the difference of squares pattern. And so we are left with 10 out here. Here's the kicker. What is the square root of x to the fourth? It's x squared, because x squared times x squared gives me x to the fourth. And the square root of negative 1, one is positive, and the other is negative. There is no such things as a sum of squares, so this part does not factor. So you just leave it alone. You can't say that's x plus 1 times x minus 1. It only works for a difference of squares. This, however, factors even more. You just keep factoring until you can't factor. And that factors x here, x there, the square root of 1, positive, negative. Now this is all done. You still might not believe that the x squared plus 1 should factor, but it doesn't. So there's no such thing as a difference or a sum of squares. So let's put right here, no such thing as sum of two squares. You can't break it down any further. Right. Let's do one more. This one's a little trickier, but I'm going to do it for you anyway. Will you see it on a test? 99.9%, most likely not. So the greatest common factor, they can all be divisible by 3, and they all have this minimum of m squared. So we are going to factor out a 3m squared. In the first term, we're going to have m to the 10th left. Notice you don't want to put m to the 6th because we add exponents when we multiply. So that's why it should be a 10. And the next one, 3 times 18 gives us 54, and we have m to the 5th. And the last one, 3 times 17 gives us 51, and we already have the m squared out there. And now, the stuff in the parentheses is not a sum of two cubes. If there's more than two terms, you want to go straight for the x factor chart. So that's what we want to do. So b is 18, and a times c is 1 times 17. And two numbers that multiply together give me 17. There's 1 times 17, and 1 plus 17 gives us the bottom number, 18. So there we have it. So we have 3m squared. This is the hard part for students to know. You're used to just writing an m and an m. Well, not going to work this way anymore. But let's go ahead and finish writing the plus 1 and the plus 17. That has not changed. Here's the difference. This is m to the 10th. So if you're going to split it up evenly, it's going to be m to the 5th here and m to the 5th there. And then it's factored completely. So that one was a hard one. If you can do that one, then that's just pretty amazing stuff there. Right. What about solving? Solving is factoring first and then using ZPP. So stuff that you've already done before. So now let's go ahead and factor and then solve. A, B, and C are equations. So whenever you see an equal sign, you can divide by things. So you can divide everything by 4 because it's the largest number you can divide by. You don't have to worry about factoring it out because it's an equation. So that's x to the 5th minus 10x to the 3rd plus 9x equals 0. Okay, now the greatest common factor, because we haven't even factored yet. Step 1 is always look for a GCF. All three of those terms have an x. We can't divide anymore by x, even though it's an equation. We never divide by a variable. So factor out an x. So the first term, you're going to have 4x to the fourth minus, for the second one, 10x squared, because you factor out one of the x's, so you're going to have one less, plus 9. And then you have 3 terms there, so we're going to make an x factor chart. So let's just do it down here. I'll do it right here. So b is negative 10, it's the middle number. A times c is the first and last, so 9. So what two numbers multiplied together give me positive 9, but added give me negative 10? Negative 1 and negative 9. So x times, this is all equal to 0, so one's going to be negative 9, one's going to be a negative 1, and this is going to be x squared. And then both of those things factor. So this is a DOS pattern, this is a DOS pattern, difference of squares. So each difference of squares has 2 sets of parentheses, so you're going to have 4 total. And so we're looking at the first one, so x and x, square root of 1 plus 1 minus 1. Second one, x and x, square root of 9, and I didn't do this, but here, you can do that if you want to, if it helps you. So we have x plus 3, x minus 3, all equal to 0. Oops. Okay, now that we factored completely and we know it's set equal to 0, we can set everything where we see an x equal to 0. We're going to have 5 answers here. First one is x equals 0. Next one is x plus 1 equals 0. Next one is x minus 1 equals 0. Next one is x plus 3 equals 0. And last one is x minus 3 equals 0. Here's one answer. Subtract 1. Here's the second answer. Add 1. Third answer. Subtract 3. Fourth answer. Add 3. Geez, 5 answers. We never had 5 answers. Here's a hint. If you look at the original problem, I hope you realize that the degree was 5. The degree tells you how many solutions are going to be. That's a preview of something we're going to learn later on in the chapter. So we had 5 solutions there. The solutions were x equals 0, negative 1, positive 1, negative 3, and positive 3. Okay, we'll do example 2. And what I'm going to do is, and you can't use ZPP until you get everything all on one side. So let's move both of these to the left side. And let's put them in standard form. So biggest exponent to smallest exponent. You can divide everything by 2. So we have x to the 5th minus 6x to the 3rd plus 8x equals 0. Now the GCF, they all have an x in common. So factor it out. First term is just going to have 1 less because you factored out one of them. Second one is going to have 1 less. I guess that's an easy way to think about it. And the third term is going to have 1 less. So it's not going to have any. And then we're going to use the x factor. B is negative 6, and A times C is 1 times 8. Negative 4, negative 2. So negative 2, negative 4. And what goes here is not just plain x, because it's x to the 4th, it's x squared. Now, here, notice these two do not factor any further because negative 2 is not a nice number you can take the square root of. Only these will factor. So we are left with x times xx. Square root of 4 is positive 2, negative 2. And this, we're going to leave it alone. Let's see how many answers we have. So set that equal to 0, this equal to 0, this equal to 0, that equal to 0. So one of our answers is x equals 0. The other is x plus 2 equals 0. A third is x minus 2 equals 0. X squared minus 2 equals 0. Let's solve each one. So subtract 2, add 2. That's 3 answers, but we should have 5 answers. Here's where the fourth and fifth one will come in. Hopefully you remember from the last chapter. So here we're going to add 2 to both sides. Now we're going to take the square root of both sides, solving by the square root method. The square root of x squared is x, and the right side is always plus or minus, and in this case, square root of 2. So we do have 5 answers. Those are 2 answers right there, a positive, the square root of 2, and the negative of the square root of 2. So that's still 5 answers. All right. And we are going to skip C because we've done enough. So let's just skip. And those are your notes for today. Have a great day, Algebra 2 students.